Hello. Yeah, so this demonstration is primarily for my students, but you might benefit from it as well. So I've got a connecting rod, and let me show you what the drawing looks like. So there is the drawing. Two parts, but I'm allowing students to model it in one part, so these two are part of the same part. They can split it later if they need to. One thing I wanted to point out, and especially to my students, are the finished surfaces on this part. So finished means it's been machined, so a part like this would come out of a casting, and then you would have all unfinished surfaces. And then you would finish what needs to be finished, such as drilling the holes, facing the top, maybe milling out the ends here, and again, more drilling of holes. So I'm showing finish marks on some of these finished surfaces, such as right here is a finished mark. So on both sides, and then I've got the top of the part is finished here, at least the top of this cylinder. The top of this cylinder, by the way, which represents this end. So this end here is, and here is this end, and then this is a cylinder here, even though it's hard to see, that is a cylinder. And so the inside, the holes are finished, the top, the bottom, and these little notches on the end. So that's what the part looks like. So if I go to my model, this is what it looks like before I add fillets. Now fillets represent, in this case, where two unfinished surfaces will come together. So if you have two finished surfaces that come together, such as here, you will have a G0 edge. If you have a finished surface that meets with an unfinished surface, such as here, you will still have a G0 edge. So I'm going to quickly, for the benefit of my students, blow through how I modeled this, and maybe, if you're careful, you can capture, what you're looking for in a future lab assignment here. So I'm going to start at the top, change my order of regeneration to my first part. You can see that's the cylinder. This is the cylinder on the small end, and then the next feature was the other side, and you can see here if I double selected that, you've got this defined distance, which, by the way, I'm working in the part drawing is in millimeters, but I'm working in inches here, so I'll apologize for not changing that over. Now, I've got the middle part. I just wanted to show you, I'm going to show you this real quickly, primarily for the, I want my students to work through some of this on their own, but the part itself, notice I don't have any overlapping geometry. So I did the project 3D elements around this cylinder, project 3D elements around this cylinder. I got two domains here. I did the trimming back as necessary here. Complete part, that's enough. And I don't want to show you too much, but so that ends up with that, and then the rest of these are just holes, including a mirror hole at the end. So what I'm going to show you here is how to do the fillets, and I'm going to require students in an assignment such as this to do one fillet only. So look at this. So got a lot of edges, a lot of faces. You might be tempted to do a face select. So if I selected that face to fillet, it would propagate out to all the G0 edges and fillet those edges. But unfortunately, which is great here, except for this finished on the end here. So you can't fillet this. So so face selection of fillets aren't working, or won't work, for at least for that. Really for this face either. So really everything here I've got to do will be edge selection. 2 millimeter fillets around these edges to distinguish to essentially where I have two unfinished surfaces coming together. So let's begin that. So I'm going to go to the edge fillet tool. I'm going to enter 3 millimeters, and let's begin selection. Who knows? So I've got tangent propagation turned on, which means when I do an edge selection, it's going to identify the topological edge, and then it's going to, where another topological edge comes tangent to it, it will jump over that tangency and keep selecting until it runs to a point that is not tangent. So when I select this edge, notice how I make sure I'm selecting an edge. It selected that entire region from that point to this point. So again, and notice when I select, I hover my mouse briefly just to make sure I'm selecting an edge. That can be very beneficial for you because you can accidentally select a face. You don't want to do that. So notice just the slight hover just to make sure I get those edges. I want to select around this. So two unfinished surfaces. Again, hovering to make sure I select the edge. unfinished surface, finished surface, so I won't need a fillet there. Unfinished to unfinished, so make sure I select edge, and let's do the bottom. And the last two will be there and there. So let's preview. Go ahead and select OK. And that's looking fine. Now, one thing I like to teach is make sure students have robust models. You get predictable change. If you make a dimension change, you're not going to blow your model up. So I've got a little pad sticking here. Notice just a little bit of a gap. So this is 3 millimeter radius. I could probably measure this distance, but it's greater than 3 millimeters, this offset here. What if it was less than 3 millimeters? That would cause an update error. So I'm going to just show you what that looks like. So I'm going to change it from 3 millimeters to, let's say, it's 0.37, I'll just make it 0.3. And so boom, there's my update error. And what happens is that fillet overlapped that outer edge, and CATIA did not like that. But there is a way to fix that. I'm going to undo. I'm going to show you how to fix that, or at least make it more robust. That's by doing the edges to keep option. So edges to keep, I would like to select that edge to keep, and that edge to keep. And we may as well do the bottom. So you won't see any changes. But if I were to come back and make that little bossy area smaller, no update error. So that added a little bit of robustness. And again, just to review that, it's back on the fillet tool. Typically, the fillet tool is going to be closed, so you've got to go to the more option, and then the edges to keep would be here. And what it does is it will keep that edge regardless of the depth of what's happening. So that just makes it a little bit more robust model. So I hope that helps, and have a great day.